It's only now that I truly understand why Elon Musk has said that Japan is a leader in high-end manufacturing. As the heart of manufacturing, electric motors hold an almost mystical power in core industries. Creating a high-quality motor requires not only a well-developed industrial system, but also a keen ear, achieving true harmony between humans and machines by recognizing sounds and identifying issues. This is the first step in making an electric motor at the Mitsubishi Electric factory. First, steel plates are rolled into a cylindrical shape and then transported forward for secondary extrusion. In the grooves, the machine applies pressure to shape and correct the steel plates until the edges seamlessly fit together. Now, we move to the second step, welding. At this stage, strip-shaped steel plates are welded onto the base surface, forming the heat dissipation structure commonly seen on motors. The assembly is then pushed into an expansion machine, where it undergoes controlled expansion to correct any microscopic errors caused by thermal expansion and contraction, improving precision. The base size of the motor is also adjusted accordingly. Next, we begin applying an anti-rust coating. This special coating significantly enhances the metal's corrosion resistance as the motor housing takes shape. Now, we move to another workshop where the iron core is made. The primary material is silicon steel sheets. Under a 400-ton high-frequency punching machine, a set of stator cores is quickly formed. The next step involves aligning and interlocking two parts before they are pressed together for reinforcement. This process strengthens the iron core, improving its stability during rotation. Afterward, calipers are used to measure the core's diameter, and traditional tools help ensure that the key slots match the required model. At this point, the iron core is fully integrated, eliminating any risk of components falling apart during grinding. With multiple iron cores now complete, we proceed to assemble another set. Due to its larger size, this assembly must be done manually. The workers install key slot inside, but some are intentionally left open to serve as ventilation channels. Afterward, the core is rolled and secured tightly into the slots, finalizing the assembly of two different types of cores. Once the extra components are removed, a massive iron core is revealed. Next, we move on to the stator assembly process. Workers first place the stator into an embedding machine, where the stator slots are securely positioned. Now, we install the insulation paper, a white insulating material that prevents direct contact between the iron core and windings, reducing potential adverse reactions. Next, we prepare the stator windings. These are round copper wires coated with polyester enamel, commonly known as enameled wires. In contrast, bare copper coils are often used in high-voltage motors, requiring stricter insulation materials. With the stator windings ready, the installation process begins. As the coil reaches a designated position, the robotic arm lifts and inserts it into the stator windings. The completed stator is then wrapped with protective tubing and secured with adhesive tape. The copper wires are heated to burn off their insulation layer before being bundled together to ensure proper electrical conduction. Next, the windings are pressed under a machine exerting dozens of tons of pressure. This compacts them into a uniform, neatly arranged structure. To prevent the winding from loosening, workers tie them securely with rope. This complex process ensures the motor's durability. Now, we conduct resistance testing. The power cable is connected to a conductivity switch, and a testing device is used to measure the resistance of the stator. Next, the stator is hoisted and fully submerged in a special liquid for long-term treatment. Now, we move on to manufacturing the rotor shaft, made from high-strength alloy steel. After cutting the metal into equal sections, it undergoes precision machining. It takes just 20 minutes to shape one rotor shaft. Meanwhile, workers prepare rotor silicon steel sheets, dividing them into multiple sets and placing them into molds. To ensure consistent key slot alignment, they make fine adjustments using specialized tools. Once the rotor is ready, an outer mold is placed on top, and molten metal is poured into the furnace to form the rotor's conductive structure. As the rotor enters the furnace, workers seal the chamber. After a short wait, the mold is removed, revealing neatly formed blades at both ends. The top burrs are then polished smooth. Next, the rotor is heated to 300 degrees Celsius. After heating, it is immediately removed and inserted into the rotor core, then left to cool naturally. Now comes a crucial step, dynamic balancing. Dynamic balancing is essential for all motor components, as it ensures the rotor stability. If the rotor wobbles or vibrates, workers trim the balancing blocks on both sides. The amount removed from each side must be equal to maintain stability. The rotor is then coated with anti-rust paint, and its axis is carefully tested to ensure horizontal and vertical alignment, an essential step to prevent bearing instability. Now, we move on to the final assembly stage. Installing the stator into the motor housing requires significant effort. Once mounted on the transport platform, surface finishing begins. The stator is secured in a drilling machine, and precise holes are drilled into the base. These holes aren't too deep and don't penetrate the entire structure. Any remaining debris must be cleared immediately. Failure to do so may result in fines. Now, the rotor is installed. This heavy component weighs at least 200 kilograms. The motor is flipped to install the side covers. Despite their small appearance, these covers are incredibly heavy. Workers use their palms to push them into place, never their fingers, as this could cause severe injuries, even with gloves on. Next, an electric impact wrench tightens the screws, securing everything firmly in place. Now comes the final quality inspection. The power supply is connected, and the motor is switched on. A crucial step follows. Workers listen for any abnormal sounds inside the motor. This process is similar to a doctor using a stethoscope. If a stethoscope were used here, it might make the job even easier. Finally, the motor is heated to allow the paint to fully adhere to the metal surface. With that, a fully assembled motor is complete. Now, let's see its real-world application. It appears to be part of a wastewater purification system. What do you think of this massive industrial motor?